Okay, we're going to get started. So my name is Mackenzie Woodman. I'm the Geology and Remote Sensing Application Specialist here at Spectral Evolution. And today I'm going to be discussing spectral analysis and material identification. And this will be the first of two parts. Today is going to focus on building a roadmap of the data processing tools in DARWin, how to operate it, how to access those tools quickly and easily. So here we'll get started. So first I'll introduce Spectral Evolution to any new attendees. Spectral Evolution is the leading manufacturer of field-based UV-Vis NAR spectrometers and spectroradiometers. We were established in 2004, so it's been about 21 years, and we're located in the Boston area in Massachusetts. So our primary application uses for our spectrometers and spectroradiometers are in hyperspectral applications, remote sensing and vegetation, mining and geology, as well as photonics and calibration transfer. So to start, I'll introduce DARWin and the toolkit that's provided in DARWin. DARWin is designed to streamline basic data analysis. We've compiled many of the most common data analysis techniques and put them into easy-to-use tools that will be available to you during data collection, both in the field and in the lab. We've ensured that all data is in ASCII format so that even if you're not using our software, it's easy to work with and to pull into any algorithms that you're using. We've also integrated quick and easy plotting for publication-ready plots. And like I said, this webinar is meant to give you a roadmap for accessing the tools quickly and easily. So when you first open DARWin, after you click on the app icon, it will prompt you with the instrument control panel. So that is the panel that's on the left. So the first thing on the instrument control panel is how to connect to the COM port. So that's how the instrument communicates with the software. The next is the measurement button. When you select the measurement button, it will open up the prompt on the right, which is what type of measurement are you going to be taking. So this will be dictated by what kind of research are you doing. Are you doing direct energy measurements, reflectance spectroscopy, or absorbance spectroscopy? And when you select these, it will select a default options for the most common options for how you're plotting with reflectance versus direct energy. So it will select your units for your plots and make it quick and easy to use. So that's the first selection that you do when you open up DARWin. So the more complicated piece here is connecting to the COM ports and identifying what COM port that is. So when you pair to the instrument via Bluetooth, it will select a COM port. This will have an incoming and outgoing connection, and DARWin will communicate through the outgoing COM port. So if you've already opened up DARWin and you haven't paired to the instrument via Bluetooth, then you won't be able to connect yet. So what you'll have to do is open up Bluetooth and devices settings, select add device, and pair with the instrument the same way you would anything else with your computer. There will be a pin that is defined by what instrument you're using, and you'll be able to find that in your instrument manual. Once you've paired to the instrument, it will say connected, but it will quickly drop out of connection. And that's because it needs the software to actually open up the connection with the COM port. So once you've made the connection, you can go back into DARWin and select the outgoing COM port, which will be defined under more Bluetooth settings. We'll open up the window that's shown on the right, which will have all of the COM ports defined. So you'll just find the serial number of the instrument that you're using, find the outgoing COM port, And then in the drop-down in the instrument control panel, you just select the correct one for that. And once you connect to the instrument, it will port in all of your calibrations associated with that instrument. If you're connecting via USB, in the dialog box in DARWin, you should see the 2 COM ports that are associated with your USB, and you connect to it via that way. So it's not as complicated as the Bluetooth connection, although both are very stable and easy to use. So the next prompt or button is the plot settings, which will open up the window on the left. And then each window subsequently is a different option in the plot settings window. So first, you choose data for single measurement plots. So that's number 1 here. When you're choosing the data for the plots, this is what are you going to be plotting on your single measurement plot. So when you're looking at one scan, what do you want represented when it populates the plot? So you can select what are you working with reference, radiance, do you want your reference to be in radiance or in detector counts, as well as target reference or detector counts. And then are you going to be working in percent reflectance or negative log reflectance? The next is choosing the column for the data table. So right of the plot will be a data table, and this will be the same thing where it's plotting in the table in columns the data that's associated with the scan that you're taking. The next is choosing data for a multi-plot. So there will be multiple measurements on this. So you'll be able to have the option of normalizing by normalized percent, normalized or convex Hull quotient, or normalized Hull quotient. And then a negative log reflectance if you'd like to plot that. And then for spectral radiometers, you have the option of target radiance or reference radiance versus target counts. Also, option 4 on the left in plot settings is the hide H2O bands. This is associated with outdoor measurements. So if you've ever taken measurements outdoors, you know that the atmosphere and the water in the atmosphere absorbs nearly all of the signal at these 2 band widths. And so what this is doing, it's not turning off data collection in those areas, but it's not plotting them. So when you have, so it doesn't blow out your y-axis when you're plotting your scans. So this is a nice option for anyone doing outdoor remote sensing. Next button, and that is the file settings button. So this is where you can select what output are you going to get in your scan files. So what are you recording with your data? So if you'd like to save your reference data, and if you'd like it in percent reflectance or negative log reflectance, if you'd like to save the radiance as well as the ratio, and your reference data, these are all options that you can select. Just know that the default will only save your reflectance percent. So if you'd like to save your reference scans, then you need to select that before you go out into the field, just to make sure that you're getting all the data that you're going to look for later when you're in the lab. And in the same way, you can choose what kind of data you're saving here and how you want it to be displayed into that folder. So the next thing is, where would you like that folder to be saved? So you can select the file path that it will save into, but by default, in the documents folder, it will create a spectral evolution folder. It will then have the serial number and name of your instrument. It will create a folder for that. And then in that folder, it will have a folder by the date. So while you're scanning, it will organize your data by date, but you can change that in the select path for file storage and change how it saves. So that's another added option for you. So once you've done that, the instrument will initialize and port in all of your calibrations, and you'll come to this screen where you have all of your options for data processing with your instrument. So I'm going to go into more detail on each of the buttons here, but the primary button here is the instrument control up in the top left. That is all of the prompts that we just went through. If you want to change your settings, you can go to instrument control in this window and go back to change any settings. So the other window that will pop up right before the screen, right before you start scanning, is it will ask you what you want to name your scans. So this could be what site are you at, what target are you scanning, and so it will initially populate with the name of your instrument and the serial number, and then I often underscore site 1 or sample site or sample 1. And then whatever you put in the title base, it will then add 0001 to it, and that will count up with every subsequent scan. And in that in the main control panel, in the main display, up in the top right, there's a next scan box. You can double click this at any time to change the name of your scans, so you can quickly switch to different samples or different site names. The other most important thing before you start scanning is to select the measurement and the optic that you're using for your measurements. So that's in the bottom left. It's highlighted in green to make it more prominent on the screen, because it's very important that you apply the correct calibration. If you're using a contact probe, you need to select contact probe. If you're using a leaf clip, you need to select leaf clip. And if you're doing radiometric calibrated lenses, you need to select the correct lens for your sampling. So here I've broken down each of the options that are on the screen when you're taking data. So the top left is the primary controls. This is where you take a reference and a target, and you can select the averaging time. This is how many scans are you going to average together for each scan. And then you have an auto integrate tick box. This will turn on auto integration. So that's our optimization step, or part of it. I recommend keeping this on for nearly any measurement. There's very rare cases where you would turn this off. But when you hit the target button, there's an auto optimization step that happens under the hood of the instrument. And so what happens here is a dark scan is collected, and then a quick scan is triggered to determine the optimum integration for each of your 3 detectors in the instrument. And then the scan will initiate with whatever averaging time you're going to happen. So if it's 40, it will take 40 scans at the optimum integration. And then after it completes the scan, it will take another dark scan, and it will average those 2 and subtract it off to make your dark correction. So with the target button, you're really getting several steps of optimization to make sure that the data quality is good. The next tool that you have is a sequence averaging tool, which allows for quick analytics of your spectral data. So I often reference whatever count that you put in here and you hit enable. Say you put 5 and enable. That means on your 5th scan, it will average the last 5 scans together to give you the average 1 through 5. It will still have all of your data broken down, each individual scan, I mean, but they will be completely, it will automatically collect that average scan so you can look at it. So if you're characterizing, say, an outcrop or transect, and you know that you're taking 10 scans at each location, you could put 10 and then have the average quickly calculated for you. So it's just a little extra convenience for you when you're in the field. The next is the time interval scan. So this is for the timed interval scan allows you to put a time period. So every 30 seconds or a minute, it will count down and then trigger another scan. And so if you're collecting, say, irradiance measurements and you wanted a scan every minute to see how the energy changes through time, or if you're over a moving river, that's an option that you can use. The next is the external trigger mode. So this will trigger, this will take your target button and put it onto the trigger on your accessory. So this could be a pistol grip, any of our accessories that have a trigger on it. It'll put your target button as the trigger on your accessory. So that's just to make it more convenient in the field. You don't need to go back to the computer or tablet and hit anything. And then the next little piece of metadata is you'll be able to do a file comment, and you can take any notes that will be associated with the scan, and it will be saved in your scan data. So that's the file comment box, and you can type in if the outcrop was wet, or if it was cloudy during measurements, or whatever you want to note there. The next is, this is when you've plotted your data and it's appeared on the plot. So this could be in a single measurement plot or a multi-plot. You have this drop down. If you right click on the graph, it will bring this prompt. So it starts with display data, and that's the window right on the right where you can display and change your settings for normalized percent, convex hull, normalized hull quotient, negative log, or radiance measurements. And then plot settings is where you can define your axes and what range you want. You can also put a smoothing filter on it if you'd like to smooth out any noise that are there, but that's optional, and you can change the values for that. And then if you plot all of your data onto here, you can export them as a CSV file, which is very convenient. And they'll appear in a CSV in columns for each with the title of the scan as the header. So that's really convenient. And then you can also put text notes on your graph and then export it as a printed graph, which is also very important for any publication-ready data. So once you've plotted everything in a multi-plot, you also have the option of sending it to some of our other tool windows. So you could send it, if you want to take a closer look at an individual scan, you can send it to a single measurement plot, or you can send multiple scans to a multi-plot if you want to look at two closely together. And then you can just double click in the legend and turn on and off any of the scans. And then there's also a calibration generator if you'd like to create a calibration based on a standardized material. That's the tool that you would use. For quick analysis in the field, you can also use the min-max average statistics form. This will allow you to do very simple statistics, calculate averages between multiple measurements and things like that. So that's a very useful tool. We also have the EZ-ID library builder and match analysis windows. So this is where you can send data from this plot and into the match analysis software. And I'll go into more detail with that in part 2 during our next webinar, but it's very useful. This is where the option for the derivatives window and the spectral math form and wavelength puck calibration is also here. So also on the right here, you can multiply a series by a constant or by another scan as well. So some spectral math. So this is what the statistics form looks like. Here it's giving you the min, mean, and max values. So this is very useful for certain applications. And then the next is your derivative spectra. Oh, and I should have mentioned that you can save all of these data outputs to for future use and save them and export them. So the derivatives forms, you can do first and second derivative, very useful for quick analysis, especially if there's subtle features that you're looking for. And so you can quickly look at it in first or second derivative, and if it's particularly noisy, you can adjust the filter with the button here on the right, with the scale bar here. You can quickly change that filter width, and then you can also export these as well. Another useful tool, these are in the tools on the top drop-down menus of the DARWin software, is a remote control keyboard shortcut configuration. So this is where you can connect something like a PowerPoint clicker. You can designate certain tools to do certain actions. So you'll be able to designate or use a PowerPoint clicker or a keystroke to take a reference scan, a target scan, and then save your last scan as the three options for these keystroke findings. So that's something that's very useful for if you're controlling the instrument remotely. So the next thing I'm going to go into is some of the features that are associated with the NaturSpec Plus. So this is the NaturSpec Plus. We've just launched it this year, and it has extra metadata tools in it, but it's very similar to the DARWin LT software, but it has extra camera, field of view, real-time field of view, and some other metadata that I'll go through that's associated with it. So, and when you're using the DARWin for NaturSpec Plus, as you can see on the left here, that's your live field of view with that circle drawn on it. This is calculating that black circle on the field of view based on the distance to the target that it's calculating with a distance finder, as well as the optic that you're using. So it will take the degree of your field of view and use the distance to calculate what is your real spot size and what are you really scanning. So as you can see here, bottom left is the reference and target. The setup is very similar, but everything is in tabs in the bottom, so you can flip through pages where it will have all of your setup for the different scans. But what's important here is at the top, it's recording your range to target, system temp, solar angle based on your GPS coordinates, which it is also collecting, as well as your voltage and your SWIR 1 and 2 temperatures. It will also use an inclinometer to find the angle that you're using. It will record that in your metadata as well. And this is a lot of this metadata, like the rangefinder and the inclinometer, is based on the SensaProbe Plus, which is associated with the NaturSpec Plus. So it's an accessory. So the difference in connecting to the instrument in this software is that it has this window that will refresh all of the port names, and it will connect to them all automatically. So you hit reset, it will disconnect all of them, and then refresh, it will start to connect automatically. So you don't even have to press the buttons to connect, but the first time that you set up the instrument, you'll have to designate what COM ports go to what. And then under scan parameters, so this is under the setup tab, you have drop-down menus for what optic are you using, what kind of measurement are you doing, and what averaging do you want to do, as well as the auto integration selection here as well. Then you have your plot selection here. So this is the same window, but it's been reorganized for ease of use with a tablet computer. So all of them are bubble selections, and you can also select units for your radiometric measurements. The other added benefit of the NaturSpec Plus is that we have timed triggering. So when you're using a trigger on an accessory, you can hold it down for a certain amount of time. So here we have, these are all in seconds. So in order to take a reference scan, you hold it down for 2.3 seconds, and then it will trigger a reference scan when you release. Whereas a quick button press will take a target scan. So it's a nice and convenient way to operate the instrument when you can use it with one button. And then this is what the SED files will look when you export them. So they're easily readable in a notepad. All data is reported in columns, and it maintains all the system conditions for each measurement. So working down from the top, you have where is the file saved, what detectors are in the instrument, what kind of measurement were you taking, and then it will have the date of the reference and then the date of the target, as well as the time of the reference and the time of the target measurement recorded. It will also record the temperature of all three detectors for the reference scan and the target scan, as well as the battery voltage between the two. And it will also record what averaging we're using for all the scans and the integrations for each scan, because those will change based on the conditions. We'll also record what 4-optic you used and what calibration you used on it, and then your GPS coordinates. And yeah, so it collects all of that metadata, and it will be there for you if you need to go back in and see why a scan may look different or why a scan didn't come out right or something like that. It will also associate any pictures of the scans. When you're using the Sensa probe, it will take a picture when you take a scan, and it will associate that with the metadata. So thank you very much for listening. Now I'm going to switch over to DARWin, and I'm going to take a quick couple scans. I'm going to connect to an instrument right now. But thank you very much for listening, and I hope this helps with all of your data collection in the future. So when I run DARWin, I just launch DARWin as the software. And if I needed to connect to it via Bluetooth, I would open up these settings here, go to Bluetooth and devices. If I hadn't connected to it already, I would hit add device, and it would be in this drop down. But since I've already connected to it, I can go into devices and then more Bluetooth settings, and then this will show you what COM port is it connected to. The instrument I'm going to be using is using COM port 6. So you can close that, go to instrument control, select COM port 6, and select connect. If I was using a USB, it would be populated right here. And so I'm going to just take a quick reflectance measurement. So select it here. I don't need to change anything here because I'm using the default settings, and I like the file path, so I'll hit OK. It will port in any calibrations that you have associated with the instrument, and it will initialize. It will ask me, what do I want to call it? I'm going to keep it the same. And now I'm operating the instrument. So the first thing to do is make sure I'm using the contact probe, because that's what I'm using for this demonstration. Select that here. Averaging, I'll bump this up to 20. That will make the scan a little bit quicker. And then I'll take a reference scan. So that's my reference scan, and then I'm going to take a scan of this leaf I have on my desk here. There we go. Now, if I wanted to use the external trigger, I would just simply hit external trigger, and all of this is grayed out because it's assumed that you're no longer using the computer to control it, but actually the triggering accessory. And then I'm going to scan this piece of lepidolite, and it will change. There you go. Now, if I wanted these to plot onto a multi-plot, I can hit the new plot button and then go on to new plot and take the same scan. And as you can see on the right, there's the instrument status that's showing me what the temperatures of the system and the integrations. And then once I have a multi-plot as the active window, I can just keep scanning and they'll keep plotting on top of one another here. So I got a couple leaves here. Yeah, so once I've done that, I can hit right-click, save all to CSV. If I wanted to look at a scan and see some information, I can show a scan header info if I want to look at the metadata while I'm in here. And more or less, that's what I wanted to cover in part 1. In part 2, I'm going to take a bunch of scans. I'm going to go through how to create a library and how to do some match analysis in EZ-ID. So kind of the next steps after you've operated the instrument, how to analyze the data using some of the more advanced tools like EZ-ID. So thank you very much for attending today, and I hope you have a good rest of your day. Thanks.